This is geometry. We're 4.9a. We're going to talk about using congruent triangles. What's going to happen when we know triangles are congruent? Then we'll be able to show that the corresponding parts are also going to be congruent. So like any proof, we always start out with trying to convince ourselves that this is possible before we look at the proof itself. So we're going to look at AB and mark that with our tick mark. DE, mark that with our tick mark. This says that angle ABC, that would have an angle marker on it, and that's going to be the same as angle DEC. Remember that the middle letter is where the angle comes to the vertex. So that's the spot that we're talking about that needs the marker on it. All right, so from here we're looking for an additional piece of information. We don't know this. This is what we're trying to get to. So we do not mark what you're trying to prove on your proof. It would get confusing because we don't know that part. This is what we want to show. So we cannot assume this. What can we assume? What do we know is the same? When you have the big X here, you know that you're going to have vertical angles. You want to get your eyes used to seeing that. So the triangles are going to be congruent. They both have a 2-ticker angle. They both have a 1-ticker angle. And they both have the non-included side. So the triangles are going to be congruent by angle, angle, side. So then the corresponding parts, there's different parts we have not talked about yet. We have not talked about segment CE and segment CB. We know that those segments have to be the same. We know that segment DC is congruent to segment AC. We know that for sure because they're corresponding parts. We would also know that angle D has to be the same as angle A. Those are all the different parts. We're only going to talk about a specific one right here. So we start with our given information. The additional bit of information, you have to decide, did this come from something they told us in the given? Like you have an angle bisector, so now you have angles congruent? Like they didn't tell us that. This was your vertical angles. So if vertical angles, then congruent angles. On our sheet for words for proofs, you can see it does our wording right here. If vertical angles, then they are congruent, or then congruent angles. So this sheet here will help you with all the wordings that we might use for proofs. Here's your hint. What comes next? So you know that we're going to use one of 5 ways. And looking here, we have 2 angles and the side that is not in between the angles. So it's considered AAS. Notice that that is not the last reason anymore, but it has to be the reason for why triangles are congruent. Now we know that DC, the first and last letter, is supposed to be congruent with its corresponding part, which is the first and last letter also. So if triangles are congruent, then corresponding parts are congruent. Now this corresponding is not the same corresponding that we talk about with parallel lines. It's actually a different, completely different corresponding. These are corresponding parts. These are if you laid the triangles on top of each other, what sides would line up. And we also have that wording on our sheet. And we wrote the extra words in here. So if triangle is congruent, then the corresponding parts are congruent. There's an abbreviation for that called CPCTC. Corresponding parts of congruent triangles are congruent. You could use that abbreviation in here instead. I definitely prefer the if-then, because if reminds you you got to talk about it earlier, and then is what you're specifically talking about right now. Okay, let's try to flip our sheet over. Take a look at a couple on this side. Now I look here and I see a lot of different triangles happening. I have triangles up on top. I have triangles here towards the bottom. I have the big triangles that include both of those put together. So we've got to identify which ones. In our proof, it could be pretty helpful. Looking there. That we're going to use BAD. We're going to use just this small triangle. I would suggest to redraw your triangle so you don't have the extra segments getting in your way. So this is A, this is D, this is B and C. Remember, when you make your plan, you don't worry about your proof at all. Just focus on what's given to you. BD, we put tick marks on there, is the same as CD. Angle, BDA, is congruent to segment CDA. Those segments are congruent. Not segments, sorry, those are angles. Those angles are congruent. Then we're looking for a third bit of information. They only gave us 2 bits of information up here, so we need to come up with our third bit of information. What would that be? We have the reflexive right here in the middle. It's the side that both triangles share, called the reflexive side. So now I'm going to prove the triangle is congruent by side, angle, side. Then I know that the remaining angles, these 2 top, like angle A's up here, BAD and CAD, those 2 would have to be congruent. So we started out with our given. We made a plan for how we can do this. In our plan, we talked about the reflexive. Segment AD is congruent to segment AD. Notice we did not have to switch the letters because it's going from the top down to the marker and from the top down to the marker the same way. The triangles are congruent by side, angle, side. We like to write the word congruence. And then why are the angles, these additional angles, congruent? If triangles are congruent, then corresponding parts are congruent. You could use an abbreviation in there called CPCTC. that could replace those words. But I prefer the words. Okay, we'll go down to our next example. Now here, there's a whole bunch of triangles being formed. There's these two on the left and the right. There's two triangles on the bottom and the top. Then there's the triangles that overlap using the bottom side. And there's the triangles that overlap on the top side. So we're going to have to decide which ones we're specifically going to use. When you look at the given information, they tell us that AD is congruent to BC. So that already rules out at least one pair of those angles, those triangles. Segment AD, that's this one here, is perpendicular. That's what this upside down T is, perpendicular, forms a right angle with DC. So that's going to make a right angle here. So that's telling us that we're going to be using a triangle that has a right angle in that corner. So this is point A, point D, and point C. So we would be also using the triangle that is just like it on this other side. We labeled those segments, and we've labeled the right angle. Now here's perpendicular. BC is perpendicular to DC. We also know, does anybody find the additional bit of information that we know for sure? Some people make a mistake here and they talk about the vertical angles that it looks like are being formed. Yes, there are vertical angles here. But when you spread the two triangles apart that you're working with, those angles no longer exist. So those are not important vertical angles to discuss. They are not vertices of our triangles. So we're not going to talk about the vertical ones. Do the triangles hold the same letters? Do they hold the same segment that's the same in both triangles? That's going to be our reflexive. Those are going to be the same. So now the triangles are going to be congruent by side angle side, and we'll be able to prove the corresponding parts are congruent. So we start with our given. Now I feel there's another step in here that was not discussed. They said that they were perpendicular. What have they not said yet? They said these sides were perpendicular. What does perpendicular make? They make right angles. So we do need to talk about the right angles. So I'm just going to make a little bit of more room underneath here. I'll write my word given in there, but write it a little bit smaller. So kind of like 1.5, 1.5, we need to say that angle ADC, comma, angle BCD are right angles. If perpendicular, then right angles. On our words for proofs, that's going to be right over here. If two lines are perpendicular, then they form right angles. So a lot of times I abbreviate that a bit and say if perpendicular, then right angles. I highlighted the most important words. So if perpendicular, if comes earlier, if happened in your proof sooner, then is it right now. These angles are congruent. Now, do we want to make them right angles? Or what do we need to say about these angles? Should we talk about how these angles make right triangles? Because we're going to use RHL. Or are we going to talk about how these right angles are congruent to each other? Because we're going to use side angle side. So we're going to talk about how these angles are congruent to each other. So still above number 2, so maybe we call this 0.75, sorry. Angle ADC is congruent to angle BCD. They are congruent to each other. If right angles, then congruent angles. In your words for proofs, that would be up here at the top. If right angles, then they are congruent. So you want to be familiar with what's on that sheet. Then we're going to talk about the reflexive. What sides or side is considered the reflexive side? DC and CD, they would be coming from this triangle. What we're looking at is a triangle that is here and a triangle that is here. Notice that both triangles are sharing this bottom bar. This bottom bar is the same in both triangles. That's called the reflexive side. That's segment DC being congruent to segment CD, the reflexive. Why are the triangles congruent to each other? So we see that we have side angle side. Now, once we know that triangles are congruent by side angle side, that's one of our 5 ways we prove triangles congruent. Now we haven't talked about AC being congruent to BD. Now we know that the other parts we were never certain about. Now we know they have to be congruent because corresponding parts, first and last letter with the first and last letter, they have to be congruent to each other. What do we put down here? Why are these parts congruent? If triangles congruent, then corresponding parts are congruent. All right, what do the arrows imply? They imply that we have our parallel sides. So AB, they have one arrow. CD has one arrow because they are parallel to each other. Then we have another set parallel to each other. Well, what are we supposed to think about as soon as we see parallel sides? Sides are parallel, what do you think about? You think about angles. You look for one pair of these angles that you want to talk about. And in the last month, it's always been this one. Alternate interior angles. In the future, we'll pick up some of the other ones. But right now, we're talking about alternate interior angles. When you see parallel, that's what you're supposed to think of. So, when you look at the parallel, so trace out either with your eyes or your pencil or even your highlighter, trace out your parallel sides and then connect those together with a segment that is shared between the two triangles. You can't come shooting down this side because it's only in one triangle. You need to use a side that is shared between both triangles. And now you can see the zigzag. So that's going to allow us to have a pair of angles congruent. Those angles are congruent. We have another pair of parallel sides. And we have that same side that we're going to talk about. So look at this zigzag. This is making this angle congruent to that angle, which is different location. And then, of course, we have the reflexive side. And if the two triangles are congruent by angle, side, angle, then we can talk about the corresponding parts are congruent. So we have our given. If parallel lines, then what type of angles were these? Alternate interior angles are congruent. If parallel lines, then alternate interior angles are congruent. That's why we know the angles are congruent. We have the reflexive side. BD is congruent to DB. We switched the letter order because we went from one tick mark to two tick marks, and we went from one tick mark, which was D, to two tick marks. So we started with B, then we started with D. That's the reflexive. We're proving our triangles. Be sure you name them in the correct order. The first triangle, it's your choice, really. So ABD would be pretty common, alphabetical order. I usually like that. Now we have to name this one in the same order. So I took A, which was the non-labeled angle. That would have to be C. Then I went to B, which was the one tick mark angle. So I have to go to D, which is the one tick mark angle. And then I ended with the two tick mark angle. So that would have to be up here at B. Once you prove the triangle's congruent, then you have the other parts you have not discussed, you did not previously know. AB, first and last letter, with CD. And they're even putting two parts together here. AD would have to be the same as CB. Those are called corresponding parts. So if triangle is congruent, then corresponding parts congruent.